subtract 1 from the other side and see if you still get the same answer.
So you trailed off there.
Yeah.
Subtract 1 from the other side and from both sides.
Like if you subtract 2 from 3 and you get 1, then it's still true.
Oh, you're talking about moving that over.
Yeah.
No, I'm talking about, I still want to keep my base here. So Robin just said an example.
Robin, say it again. Robin, what'd you say? Robin doesn't know what you said.
She missed her genius. There we go.
I do sort of remember it. I'm just trying to figure out the wording.
You're talking about subtracting 1.
Yeah, move it from one side to the other. Can't subtract from both sides.
Not, subtract 1 from both sides, or add 1 from both sides, or I can just always add a constant to both sides of any equation and it's still true.
Right.
If xy minus 3y equals z, well, if I add 1 to both sides, it's still a true statement.
Yeah.
So if my potential energy formula is mgh plus some constant, well, when I do u initial minus u final, I get mgh initial plus the constant minus mgh final plus the constant. The constants are going to cancel out every time.
Yeah.
So the formula for the potential energy, mgh is the base, and that's what a lot of books will just say, but it's mgh plus any constant I want.
Why would you specify that?
Because this allows us to set 0 wherever we want.
It allows us to make changes like parabola transformations and stuff.
Nothing so sophisticated. The primary reason is so that we can establish where potential energy is 0 anywhere we want, which makes the math easier.
So this is a true question.
Now, some students will refuse to do that. They'll always set h is equal to 0 at the ground. Sure. You'll invite the extra work. So, the potential energy formula for the conservative force of weight is this. G is right there. So if G is relatively constant, this is the formula. If the formula, well, let's set up a little chart here. So the conservative force, we'll do weight mgh plus a constant. This is our potential energy formula. Generalized gravitation. Gravitational force. Probably should just done the shorthand, F sub G. It is negative big G mass 1 mass 2 over R plus C. And it's not R squared. It looks a whole lot like the force, generalized force formula, except there's a minus in front and it's just a plain old R.
I can't read it. What's on the top of that fraction?
What is on the top of the fraction? That's negative big G mass 1 mass 2.
That's a G?
That is a G. If we're dealing with the elastic force, F sub S, and the reason I do F sub S for the elastic force is because F sub E I reserve for electric force. This is S as in spring. The formula looks a lot like the kinetic energy, but it's not. It's 1/2 lowercase k delta x squared. K is something known as the spring constant. It deals with how stiff is the spring or the elastic material. And delta x is how far the spring or elastic material is displaced from its equilibrium.
What's that word above gravitational force?
Generalized. The electric force and its potential energy formula will keep as a mystery for now. I know.
So disappointing.
How's it?
What another?
However, given what we have right here, we can now derive the Schwarzschild radius.
The what?
Force field radius.
Schwarzschild. Schwarzschild. Throw it with a German accent. He was a German physicist
Can
that
you
during
spell
World
that
War
for me?
I got hit in a gas attack. I don't know whether it was in the Senate. And was put in the hospital, and while he was recovering, he worked on physics. He used the newly formed theory of general relativity and derived in essence, the size of the black hole. He did ultimately succumb from his injuries from the war,
Which war?
but
Two
did
or one?
manage to produce rather important paper.
Which one? 2, 1, or bird?
One, World War I.
Okay.
Gas attack. They-
I'm shocked.
They weren't gas attacks in World War II. Not that
Outside of labor camps and death.
Yeah, I'm not sure if that counts as an attack.
Assault?
Yeah, I think that's probably a better word. In open battle, I have not heard of any gas attacks because you basically had a group of generals who
Since
had
the
gone
first
through World
one?
War I and knew the horrors of mustard gas, etc.
Oh yeah, it suffocates you. Because it's heavier than air.
It's more than that, it burns. It burns your lungs.
Yeah, it's like drinking menthol. Or inhaling it.
The guy who developed,
Zyklon B? No, wait, that was
That
World War
was the-
II?
yeah, but I think it's the same guy.
Yeah.
And also, his wife was horrified, it was during World War I, his wife was horrified at what he had done.
I'm not
One
surprised.
of the two wars. She ends up killing herself.
Oh, sugar!
And what he did the day after she killed herself was he went back to work.
Yeah, it's weird.
I'm not sure weird is really captures the horror. He was a chemist. I think that sums it up.
Oh, evil.
That's right. Only one chemist wasn't evil. Which one? Who was it?
There's so many.